on intuitionistic supra pre-open sets. Well, as for the intuitionistic sets, they've been introduced by Choker as a crisp version of Atanasov's intuitionistic fuzzy sets. And Choker's sets are also known as orthopairs. Assume that we have an unempty universe X. We define intuitionistic set IS on X as an ordered pair consisting of two components which have empty intersection, as we can read here. Sometimes we call these components AT, the set of members of A truth, and AF, false, the set of non-members. What is gravely important is the fact that basic operations on intuitionistic sets are defined in a quite specific manner. For example, union of two intuitionistic sets is the set, gives us another intuitionistic set consisting of the union of truth components and the intersection of false non-member components. Something similar is here in case of intersection. Moreover, we should remember that complement of an intuitionistic set consists of A2, A1. So we just replace truth set with false set. Also, the notion of inclusion is specific. We expect that truth set of A is contained in truth set of B, while false set of B is contained in false set of A, as it's written here. Okay. Moreover, we have these two special sets, X empty set and empty set X. They can be considered as intuitionistic counterparts of the whole universe and empty set. And one can prove that the set of all intuitionistic sets on the universe X with operations of union, intersection, and complement forms De Morgan algebra. We have idempotency, commutativity, associativity, distributivity, absorption, and De Morgan laws. As for the intuitionistic topological spaces, they've been also defined by Choker more than 20 years ago. And an intuitionistic topology on a non-empty set of X is a family tau of intuitionistic sets which satisfies the following actions. And as you can see here, they are typical actions of any topological space, but we should remember that we are in the universe of intuitionistic sets and that all these operations of intersection and of union are intuitionistic. And of course, the elements of tau are called intuitionistic open sets and their complements are intuitionistic closed sets. And we have the following notions of interior and closure, which are also standard. For example, interior is considered as a union of all open sets contained in our set A. Now let us assume that the condition number 2, namely the fact that topology is closed under finite intersections, that this condition has been dropped. Well, in this way we obtain intuitionistic supratopological space. It can be considered as an intuitionistic version of supratopology in the sense of Masur, or strong generalized topology in the sense of Chasser. So there is a closure under arbitrary unions, and the whole universe and the empty set are also open. Intuitionistic supratopological spaces were studied, for example, by Vidyarani and Jesintha Jebarani in 2020 in the context of supra pre-open sets. We shall use symbol mu to speak about intuitionistic supratopologies, and supra interiors and closures will be denoted in the following manner, as one could expect. Intuitionistic mu interior of A, intuitionistic mu closure of A. Assume that X with generalized supratopology mu is an intuitionistic supratopological space, and then we say that an intuitionistic set A is called intuitionistic supra, pre-open, if and only if the following holds. A is contained in interior of closure. B open, if A is contained in interior, in the closure of interior of A, in the union of closure of interior and interior of closure. Yes, this is proper formulation. And alpha open, if and only if our set is contained in the interior of closure of interior of itself. Of course, these notions are taken from the ordinary topological spaces, which are not necessarily supra and not intuitionistic. Well, for example, Vidyarani and Jesintha Jebarani, they prove that every intuitionistic supra open set is an intuitionistic supra alpha open set, and the converse need not be true. We may consider the following space where X consists of 3 elements, A, B, C, and our supra topology is here. 2 non-trivial elements, and of course the whole universe and the empty set. And this set, B, AB empty set, is an intuitionistic supra alpha open set, but not intuitionistic supra open set. Well, it's because, well, it's not supra open because it does not belong to mu. This is obvious. Now we may calculate interior of this set B, and this interior is consists is a new intuitionistic set consisting of singletons of A and C. Note that A is contained in our AB here, and this empty set, empty set as such, is contained in C. Yes, we remember the idea of inclusion in case of intuitionistic sets. Now we may calculate the closure of this AC set, and the closure is here. It's the whole universe in some sense. It's X empty set. So, of course, B is contained in this set, as one can easily calculate. We may also prove that each intuitionistic supra alpha open set is intuitionistic supra pre-open set, and that each ISPOS pre-open set is ISBOS, and the converses are not true. For example, as for the second theorem, this one, or rather for the counterexample, consider this universe ABC and consider this supratopology. Here we have the set of closed sets in this topology, in this supratopology, of course. And then we may consider the following set D, consisting of an ordered pair singleton of A and empty set. And now one can perform all this boring, tiring, sometimes maybe irritating, but sometimes maybe also interesting calculations to prove that D is ISBOS but not ISPOS. So it's B open but not pre-open in terms of supratopology. For example, let us calculate interior of closure of D. D is closed, so its closure is just D. Now its interior consists of, now its interior is this set. Empty set and singleton of A. Okay, and clearly D is not contained in this set, so it does not satisfy the very condition of pre-open set, which was here. So it's not ISPOS. Now you should prove that it's ISBOS. We leave it as a kind of exercise. Finally, our authors established the following diagram of relationships between various classes of sets. And they define intuitionistic supra pre-interior and pre-closure in a manner analogous to the one used in case of ordinary intuitionistic topology, or in general in case of ordinary topology. And then they prove that, for example, A is equal to its pre-closure if and only if A is pre-closed, and so on for interiors and pre-open sets. As we could expect, the following identity holds, and also the following conclusions. If A is contained in B, then, for example, pre-closure of A is contained in pre-closure of B, and the same with interiors. And as one could expect, it's possible to formulate various definitions of continuous functions. And they are all based on the idea of considering pre-images of intuitionistic supra, open alpha, open pre-open, and B-open sets. And this has been made by our authors. Here is their paper on intuitionistic supra pre-open sets. And we've used their examples or counterexamples. However, we performed more calculations, yes. So thank you very much for your attention.